Your FastMCP server works perfectly in Cursor, but what if you need to tweak the command, add dependencies, or enforce a specific Python version, all without breaking the isolated environment? We'll manually configure the mcp.json file to define exactly how Cursor should run your server, from the command and arguments down to project paths and package dependencies. Here, how to take full control of the execution environment.
MCP servers, dice roller, command, UV, args, run, Python 3.11, project, path to project, with FastMCP, run, path/to/your/server, Pi.
This demonstrates the configuration as code pattern for tool integration, where server execution parameters are declared in a structured JSON format rather than hard-coded in scripts. The approach treats server deployment as an infrastructure concern, separating runtime configuration from application logic. What makes this distinctive is how it enables reproducible environments through declarative specifications that can be version controlled and shared across teams. The pattern works by externalizing all execution context, Python version, dependencies, entry points, and environment variables into a single configuration artifact. This creates a clear boundary between what the server does, defined in Python, and how it runs, defined in JSON, allowing different deployment scenarios without modifying the core implementation. The declarative nature makes it inherently portable across development, testing, and production environments while maintaining consistency. This approach matters because it solves the works on my machine problem for AI tool integrations. By capturing all runtime requirements explicitly, you eliminate implicit environment assumptions that cause deployment failures. It's particularly valuable for AI assistant workflows where tools must run in isolated sandboxes, and for teams needing to standardize how custom tools are deployed across different projects or environments. The trade-off is initial setup complexity, but the payoff comes in long-term maintainability and reliability. Let's break it down line by line. This opens a JSON configuration object. FastMCP uses this structure to define server configurations, tool registrations, and runtime parameters in a standardized, declarative format.
MCP servers.
This defines the MCP server configuration block. It's the root key where all server instances are declared, each with their own execution parameters. Follows the standard FastMCP configuration pattern for multi-server deployments.
Dice roller.
This defines a named server instance called dice roller in the MCP configuration. The key serves as both an identifier for this specific server and determines the command line name used to start it via FastMCP's CLI.
Command, UV.
Specifies UV as the process runner, the modern Python launcher that replaces Python M. Handles faster startup, better dependency isolation, and proper virtualenv activation compared to raw Python execution.
Args.
This defines the command line arguments array for the process. Each string in this list becomes a separate argument when executing the UV command, enabling precise control over runtime behavior like Python version selection and project configuration.
Run.
This is the FastMCP execution command. It tells the server to start running the specified Python file as an MCP service, exposing all decorated tools to connected clients. Without this, the server would only load configuration without activating the service.
Python 3.11.
This explicitly sets the Python version to 3.11 for the FastMCP server process. Version pinning eliminates works on my machine issues by guaranteeing consistent runtime behavior across environments.
Project path to project.
Specifies the project root directory for the Uvicorn server. This ensures proper module resolution and virtual environment isolation, preventing import errors from incorrect working directories.
With FastMCP.
This enables FastMCP's plugin system by explicitly loading the FastMCP extension. Required for tool registration, server-side validation, and AI model integration. Without it, your tools won't be discoverable by connected clients.
FastMCP.
This specifies the FastMCP CLI command, telling the runner to execute in FastMCP server mode. Without this argument, the process would run as a generic Python script instead of launching an MCP-compatible server.
Run.
This is the FastMCP command to execute your server script. Without it, the CLI would only validate the configuration instead of actually running your service.
Path / your /server. Pi.
This specifies the entry point file for your FastMCP server. The path must point to your server. Pi implementation containing the @mcp tool decorated functions, as this is where FastMCP loads all exposed tools from. This closes the args array for the dice roller server configuration. JSON requires proper array termination, and this ensures the command line arguments are correctly structured before the next configuration block. This closing brace terminates the dice roller server configuration block, completing its definition within the MCP server's object. It maintains proper JSON structure, ensuring the configuration is valid and parsable by the FastMCP runtime. This closing brace terminates the MCP server's configuration block, finalizing the server definition for the dice roller service. It ensures proper JSON structure, preventing syntax errors when FastMCP parses the configuration. This closing brace terminates the JSON configuration object. It finalizes the server definition for FastMCP's process manager, ensuring the entire structure is valid and parsable. FastMCP configuration pattern. The mcp.json configuration file bridges your Python server code with the MCP client environment, using UV to manage dependencies and execution contexts. The order of arguments in the args array matters. Python version and project settings must precede package specifications to avoid silent failures. This declarative approach lets you version control your entire server environment, from Python runtime to environment variables, in a single JSON file.
The configuration that disappears into the client becomes the environment that shapes every call.